Hello friends and neighbors, and welcome to Electricity 101. This crash course is especially designed for those who know electricity comes out of a wall outlet, but not much more. Let's see if I can explain it in simple terms. To understand electricity, you have to start with the atom, which has a nucleus surrounded by orbiting electrons. In some atoms, these electrons are tightly bound and cannot be easily dislodged from their orbits. This accounts for insulators like glass, rubber, and plastic. In other atoms, the outer electrons can be dislodged. They are called free electrons. This accounts for good conductors like gold, silver, and copper. It is the motion of free electrons through a conductor that constitutes an electric current. Electrons move from an excess of electrons, called a negative charge, to a deficiency of electrons called a positive charge. We can make electrons move or make electricity in 6 ways: with heat, a thermocouple; with light, a photocell; with pressure, the crystal in a phonograph pickup; with friction, walking across a carpet on a dry day and touching a doorknob, you'll get a little shock; with chemical action, a battery; and by magnetic action, a generator. So far, magnetic action is the only practical way to meet a tremendous demand for electricity, although solar energy may someday take over. Electricity and magnetism are so closely related, you might even say they are interchangeable. Magnetism makes electricity, and electricity makes magnetism. I will demonstrate this using a galvanometer. This is a galvanometer, a vintage galvanometer, made in the 1950s by the Welsh Scientific Company. It is named after Luigi Galvani, the 18th century physicist. You may remember that he was the man who touched a dead frog's leg with an electric spark and made it jump. The galvanometer differs from ordinary voltmeters in that 0 is represented by the needle being straight up and down in the middle. Positive voltage is indicated when the needle deflects to the right, and negative voltage is indicated when the needle deflects to the left. Here's a good example of magnetism making electricity. I have a spool of copper magnet wire and a powerful neodymium magnet. When I move the magnetic field across the wire, you see a response on the galvanometer. I can also hold the magnet still and move the coil of wire with the very same results. When both the coil and the magnet are stationary, nothing happens. The needle remains at 0. This illustrates an important point about electricity. It takes some form of energy to make electricity. In this case, it was kinetic energy, energy of motion. The coil or the magnet had to be in motion. There was no free lunch. The necessary energy to generate service electricity can come from environmentally safe sources like hydroelectric, or from harmful sources like burning oil or coal. And of course, there is atomic energy, highly controversial. Here is another example of magnetism making electricity. This is a magnetogenerator. These were once used in telephones and in military field equipment. Here we have 3 horseshoe magnets. Mounted between the poles of these magnets is an armature with hundreds of turns of insulated wire. When I spin the armature using kinetic energy, we get a reading on the voltmeter. This small magneto delivers about 40 volts. Now let's see how electricity produces magnetism. Here I have a ferrite antenna rod wound with many turns of magnet wire. Ferrite, by the way, means iron. Right now it's completely inert, but if I connect this coil to a source of DC electricity, either a battery or my DC power supply, we now have a magnet called an electromagnet. Here is a very good practical example of an electromagnet. This is called a solenoid. These are used in washing machines to control the water flow. Maybe you have heard the clinking sound when they are activated. Inside the coil of wire is a movable shaft. When the coil of wire is charged with DC voltage, the shaft will be pulled in. This action can be used to control water valves or any other mechanical function. The fact that we are totally dependent on electricity is dramatically illustrated for me on the rare occasions when the service electricity goes out, especially after dark. The whole house becomes black, cold, and lifeless. Nothing works. It's almost frightening. That's it for Electricity 101. I hope I have given some of you a slight respite from COVID-19 and politics. Thank you all for watching, and stay well.